This is one of a series of videos produced by the Further Mathematics Support Program for A-Level Mathematics Revision. In this particular video I'm looking at the AQA D2 specification, and this is question 2 from the June 2011 paper. The question starts off by giving us a table of times that 5 people, named A, B, C, D and E, take to solve 5 puzzles, 1, 2, 3, 4 and 5. And the question simply says use the Hungarian algorithm to find the minimum time for completing the 5 puzzles. So but it says first of all, by reducing the columns first and then the rows, show that the table of values is given by this particular table, where we have to find the value of the constant k. Question goes on to say that the zeros in the table can be covered with 1 horizontal and 3 vertical lines, so we have to show that, and then to complete the algorithm using augmentation. Once we've done that, it says we need to find the possible ways of allocating the 5 people to the puzzles so that the total time is minimized, and to find that minimum time. And finally, just an explanation mark for saying how we could modify the original table so that it would produce a maximum time for completing the puzzles. The first part of the question then asks us to use column reduction. So by that we can subtract from each column the smallest number. So taking the column A, 13, column B, 12, C, 15, and then 12, and finally 14. So doing that one at a time, the first column A becomes 3, 1, 1, 2, 0. The next column becomes 1, 3, I beg your pardon, 1, 4, 0, 3, 5. The next one, subtracting 15, becomes 0, 1, 3, 2, 1. Taking 12 away from the next one, 4, 2, 1, 0, 2. And finally, subtracting 14 comes 1, 4, 2, 0, and 1. So that's the column reduction done. And following that, then we can do row reduction. So this time subtracting rows, but you'll see that actually the rows have got zeros in them apart from row 2. So if we just transfer across, the first row will stay the same, 3, 1, 0, 4, 1. Row 2 we can subtract 1 from, so that becomes 0, 3, 0, 1, 3. And then the other rows stay the same, 1, 0, 3, 1, 2, 2, 3, 2, 0, 0, and 0, 5, 1, 2, 1. So indeed we have shown that the table produced is as in the question, and the value of k here is given by this value here equal to 3. So k equals 3. The marking for that part of the question was actually just to give very simple 2 marks, one for a method and one for an answer. So the method mark getting to here and an A mark here, just the 2 marks for that part of the question. Well, we've now got this table, and we're asked first of all to show that we can cover the zeros with 1 horizontal and 3 vertical lines. So we can do that. I mean, it's an easy thing to see that if we put a horizontal line through row 4, so there's one horizontal line going through those zeros, and then we will need vertical lines through A, B and C. That covers all of the zeros in the table. So it's just a simple mark for doing that. We now have a situation where we can use augmentation. The idea of this is that we're going to produce another zeros in our table, and we do it by subtracting from each of the uncovered squares, so these ones here, the largest amount we can so that the numbers stay 0 or positive. So in other words, we can subtract 1. So we can augment this table by 1 by subtracting 1, so the augmentation value, if you like. And we must add that value rather to where there is an intersection of two lines. Everything else is going to stay the same. So when we complete that procedure, then the top row becomes 3, 1, 0, 3, 0. The next row is 0, 3, 0, 0, 2. Then 1, 0, 3, 0, 1. And now finally we're adding, sorry, not finally, the next row we're adding to the first three elements 3, 4, 3, and then these two remain the same, 0 and 0. The final row, the first three elements stay the same, 0, 5, 1, and then 1 and 0. We can now see that every single column has got a 0 or at least one 0, and every single row has at least one 0. So therefore we now need 5 lines are now needed. Right, so there were 3 marks available there. A B1 mark for getting these lines in the correct way, and then M1 and A1 for doing the augmentation correctly. The next part of the question asks us to find the possible ways of allocating the 5 people to the puzzle so that we have a minimum time. In other words, we've got to use the zeros. So if we first of all look at column B, you can see that B has only got 1 0 there. So it must give us the puzzle 3 must be done by B. After that, there's a little bit of choice. So let's go through the turn. Let's give A to puzzle 2, and then moving along, that means C must do puzzle 1. D must therefore do 4, which leaves E doing 5. So that's one allocation. Now we need to write that down over the thing. So what we'd normally just put is that we've got A doing 2, B 3, C 1, D 4 and E 5. But there are other possibilities. It would be possible for us for A to do 5. We still have B doing 3, but then there is a choice. C can stay doing 1, but then we have D is therefore doing 4. I beg your pardon, D must then do 2, because we must therefore have 4 done by E. So there's one other version. So let me write that one out. So that is A is doing 5, B must do 3, this is C doing 1, D does 3, so that again D does 2, and E does 4. The one further version that we could do is to change C from doing puzzle 1 to puzzle 2. So let's look at that one. So again we have A doing 5 here, C doing puzzle 2, and B still has to do 3. It's the only one available to 3, but that leaves us with the options then, and we can see that we would have D doing 4 and E doing 1. So there's a third thing that is possible. So that was A5, B3 as with all of them, C2, D4 and E1. And that gives you the 3 different versions that you can. Now to actually get the value of that, or the minimum time, then we can transfer one of those patterns onto the times in the table at the bottom there. So let's take the yellow pattern for example. Then that would give us here the 14, 12, 15, 12 and 15. So in total there, that gives us a minimum time equal to 68 minutes. The marking for this part of the question was simply to give 3 marks for each of these different allocations. So B1, B1, B1 and a mark for the time 68. In the final part of the question then, we're asked to explain how we would modify the original table if we're trying to find maximum values. There are different ways of explaining this. One way is to say that we replace x by n minus x. In other words, we subtract each number from some value. And quite often we'd say that n is the largest value. An alternative to that, which explains why you're maximizing, is to say that we make all values negative. In other words, we simply multiply them all by -1 and then add. Now obviously those two things are equivalent. But the reason for the second one is that you're explaining that you're making it negative, which is why it's going to be maximizing rather than minimizing, because then you are you're finding the minimum negative value, which is equivalent to maximizing. Anyway, whichever way you decide to explain it, there was simply a single mark there, which was given for that explanation. Right, that completes that particular question, and you can find other information and further questions at www.furthermaths.org.uk.